Now that you know what a base is and an exponent is, let's see how we can make use of that definition. If you want to use this definition, 2 to the third times 2 to the 4 is going to be what? If you are a mathematician, you resort back to the definition. And so we have 2 to the third is 3 copies of 2. 2 to the 4 is 4 copies of 2 together. And now if you look at just this part here, if you just look at this part, 2 is the base, and there are 7 copies of 2, so your answer should be 2 to the 7. And you got that because there were 3. If you were to count, you have 3 here, 4 are here. Together we have 7 2, so it's going to be 2 to the 7, which is really 3 plus 4. So you're observing how when you have the same base and you're multiplying so that you have different exponents here, you simply are counting how many 2's you have and you end up with 3 plus 4. How about you try this one on your own? I'll give you a few moments. This would be important to try to see if you understand what happens. Oh, are you trying? Are you just waiting for me to give you the answer? Come on, go ahead. I'll give you another few seconds. Write it all out. Remember, 3 is the base, 2 is the exponent, 3 is the base, 5 is the exponent. You're multiplying it together. Yes, then it's going to be 2 3's here, 5 3's here. Together, we're going to end up with 7 3's. But they came because you had 2 and 5 together, added together. So you start to see a pattern. Mathematicians are very efficient. And so when you see a pattern here and a pattern here, and logically, you can see how every time you encounter a situation, we have the same base, different exponents, and you're multiplying together, looks like we could add the exponents, right? Of course, you would have to verify it for sure, but that looks like the pattern. So if you want to be efficient, and I want to do the problem 4 to the power 22 and 4 to the power 100, there is no way I want to write 22 fours and then 100 fours and then count how many fours I got. So if you continue, let's do another example, 10 squared and 10 to the 4. You have 2 10s here, 4 10s here, which will end up with 10 to the 6. So this is a pattern we've been observing now. This is the third example we've done. So continue with that pattern and see, just ignore that dot there. I'll fix that later. But for now, take a look at this example and see if on your own you can write it without having to write 22 fours and 100 fours. What do you think the answer will be? Don't just wait for me to give the answer. Come on, you could do it. Even if you cannot do it, it is important to at least try. You know, having wrong answers is actually part of doing mathematics. You don't always have to be perfect. In fact, mathematicians, when they're discovering new things, they make lots of mistakes. And then by making mistakes, you say, oh yeah, this was a mistake. Nope, that doesn't work. This works. And that gives you a process and understanding of what is happening to your own brain processes. So do attempt, at least try and answer before you continue. You can pause the video and think about it. All right, so most of you got that it's going to become 4 to the power 122. And that's because you're going to have 22 fours and 100 fours, and then multiplying together will give you 122 fours. So base is 4 and the power is 122. How about this? Again, you have to resort back on your definition. 10 squared to the power 4. 4 is the exponent, 10 squared is the base. So you're going to have 10 squared, 10 squared, 10 squared, 10 squared. 4 copies of it, because that's what this exponent is telling you to do. What about each of these 10 squares? If you expand that, you see you're going to have copies of 2 10s 4 times. So 1, 2, 3, 4. But now you want to write that as one base and one exponent. So what do you think we should write? Go ahead and attempt it on your own first. Yes, it's going to become 2 and 2 and 2 and 2. That's going to give you 4 plus 4, 8. So our answer will be 10 to the power 8. In other words, look at what's happening here. You're going to have 2 times 4. That's different than this example here where you had 2 plus 4. Why is it a plus 4 here, but a multiplication by 4 here? Can anyone think about why that is? Here you have 2 tens multiplied by 4 tens, whereas we have here 2 tens, 2 tens, 2 tens, 2 tens. So according to what we've been doing, we're adding the exponent. So you're adding the exponent 2 4 times. When you add 2 4 times, that becomes 2 times 4. But when you're simply just having 2 tens multiplied by 4 tens, then you're just going to end up with 6 tens, or 2 plus 4 tens. You have 2 plus 4 copies of 10. That's how you can think of it. Whereas here you have 2 times 4 copies of 10. Again, 2 plus 4 copies of 10 here. And here you're having 2 times 4 copies of 10. This is an extremely important distinction between example number 3 and example number 5. And so see if you can now use that observations that we've made and do the following examples. So go ahead, do try, please do try, and don't wait for me to give you the answer. This way you can verify why you're doing something and if your answer is correct, because after this set of examples, you're going to have a video log question set. So here we have basis 5x plus 7. You have 8 copies and 3 copies, so you're going to get 11 copies total, and so that would be the answer in the simplified form. How about this? Well, we can't really say how to do this right away unless you do the following. Inside the bracket, you can see you have 2 copies of 3 and 5 copies of 3 multiplied together. That will give you 7 copies of 3. And then you still have this 2. So now you have 2 copies of 3 to the 7. So it will be 3 to the power 7 times 2. Why times? Because you have 2 copies of 3 to the 7. And then your answer will be 3 to the 14 because 7 times 2 is 14. All right, let's see this. It doesn't really matter what the base is. As long as you have the same base, you can combine the powers together, right? So don't be thrown off just because something looks difficult. So don't make up your mind. No discrimination allowed here. All right, let's do the next one. All right, we have 3 copies of this. 3 copies of this, so it's going to end up with 4 times 3 or 12 copies of it. Again, 3 copies of that. So 2x plus 4 to the power 4. This tells you you have 4 copies of 2x plus 4 3 times. That's how you read it. As we said before, don't worry if you don't know what this notation g of x is. No matter what the base is, as long as you have the same base and you have different exponents, you're going to combine it in the same exact manner because we are processing what exponent and base the meaning is. What do you think we should do here? Well, c squared, c cubed. So that alone will give you c to the 5, right? Now what? Okay, now we have 4 copies of c to the 5. So that's going to be 5 times 4 or 20 copies of c. This negative sign, you can see how it belongs to the whole thing. So this is going to be the final answer. This is now going to allow you to do the next example set for your video log questions. Sorry, for the next part now, get your paper pencil ready for your video log questions. Pause the video at any time, rewind if necessary. It's going to be similar to the previous set of examples that you got. For all the problems below, you're going to do exactly what we did in the previous examples. Combine them and write it in the form 1 base, 1 exponent. When you see something like this and there is no clear multiplication sign there, just assume there's a multiplication sign there. That's the convention. All right, here we go. I'll do the first one for you so that You know how to do it and what to write. So we have bases 2/3, 3 copies, and 5 copies. So your answer, this is how you're going to write. So this is what you should be writing in your notebook. 2 to the third, 2/3 to the power 3, 2/3 to power 5 is going to give you this. 2/3 to power 8. There are 8 copies of 2/3. All right, you're on your own for the next few. Let's go. Don't forget, remember what your base is and what your exponent is. If things are going too fast, you can always pause the video after every problem, solve it, and then continue. Just keep track of the base, the exponent, and the meaning. Always keep in your head what the meaning of the exponent is while you're doing the problems. Always pause if you run out of time and it's going too fast. That's why this is a video log question, so you can stop whenever you want, take as much time as you need to solve the problems. Eventually, it should just be really quick. You should be able to see, for example, here, 1/3 to power 9. That's how fast you should be able to do. I just did that one for you. That's okay. So keep going. Now that you have done all these examples, we can summarize what you have done so far. A lot of times it's important to do a set and take an overview so that every time you go forward, you know what you had, before, so it's not lost. This definition for any counting numbers n and m, and for all real numbers a, and in fact you can replace the real numbers with any of the mathematical objects we've looked at so far, as long as you remember this is the base, this is the exponent. So over here you have a to power n times a to power m gives you a to power n plus m. Why is that? So don't try to memorize this as a rule, but remember the logic behind it. You had n copies of A and another m copies of A multiplied together, so you got n plus m copies of A. Over here you have m copies of n copies of A. M copies of n copies of A. That's why it's n times m. So do make sure you have the distinction between when to add exponents and when to multiply exponents. Don't think of it as a rule, but assimilate what the definition really means. Because a rule, what if I memorize something and I forget it later? But if I know what the meaning is, I can always redraw upon my logic and get the answer. So make sure you understand the difference between this. You can always rewind and go to the previous set of lectures to do examples until you have assimilated it. If I woke you up from sleep and said, what is 2 to the third times 2 to the 5th? 2 to the third, 2 to the 5th should give you 2 to the 8th. You should be able to say that in an instant.